Hey everyone, and today we're going to be taking a look at product rule for differentiation. I guess there's like dot product rule, I guess. Completely different. We're going to be looking at product rule for differentiation, when you use it, what product rule actually is, and how to actually use it. So I guess we should start with, what is product rule? Well, product rule states that if you take the derivative, oh, that's a bad D. Anyway, d dx of sum f of x times g of x, as the name suggests, it is a product, meaning you use it when your function is composed of a product of two other functions. If we want to differentiate f of x times g of x, you would first take the derivative of f of x, so f prime of x, multiplied by the original g of x, and we add the derivative of g of x, so g prime of x, multiplied by the original f of x. Now this is relatively simple, and we're going to keep this in mind as we do some examples. And it can get a little tougher when you do product rule that involves other rules nested inside of it, for instance, product and a chain rule or product and a quotient rule. But for now, we're going to be looking at a pretty simple example. Let's say f of x is equal to just some product of polynomials. So let's say 3x squared plus 6 multiplied by x to the fourth plus 7x. If we were to apply product rule here, of course, we could just multiply all of them out, so we could, FOIL it out, 3x squared times x to the fourth and whatnot, but this is about product rules, so we're going to be using that. So, first off, we can assign 3x squared plus 6 to be our f of x, so if we differentiate according to product rule, we first take the derivative of f prime of x, f of x. So we differentiate 3x squared plus 6. This gets us 6x, just 6x, and then we multiply by g of x, so it's still multiplied by x to the fourth plus 7x, and now we add g prime of x, which in this case is x to the fourth plus 7x, g prime of x would be differentiating x to the fourth plus 7x. So this gets us 3x, sorry, not 3x, I'm stupid. Oh no, I messed it up. Alright, there we go. 4x to the third plus 7, and now we multiply by the original f of x, which is just 3x squared plus 6. Now this is a pretty basic example, super simple, just polynomials, but you're not always going to have polynomials, and furthermore, you're not always going to have just a product rule. You might have product rule and chain rule, which is what we're going to be taking a look at next. So let me just fill this back up. Oh, okay, that was a little pathetic, but anyway, let's say that f of x, or function, is equal to x minus cosine of x, and this is one thing, x minus cosine of x multiplied by ln of 2x cubed plus 6x. Now, this is a little tougher because now, while x minus cosine of x is pretty simple to differentiate, ln of 2x cubed plus 6x is not. You're going to need chain rule on top of product rule for this whole function, so it's going to be a little harder, but we can work through the algebra essentially. So first, we'll define x minus cosine of x. That is our first part that we have to differentiate. So x minus cosine of x, we differentiate x as just 1. Minus cosine of x differentiates into positive sine of x, so we have plus sine of x and of course we just multiply by the original. So we have, or rather, the g of x that's not differentiated, which is just ln of 2x cubed plus 6x. And now we add the derivative of ln of 2x cubed plus 6x. Now, in order to differentiate this, we're going to need chain rule, so that states that we differentiate the inside multiplied by the derivative of the outside, the whole thing. So the derivative of the inside is simply, it's a bad 6, but whatever, 6x squared plus 6. And now we multiply by the derivative of ln of this, which is just 1 over that. So 1 over 2x cubed plus 6x. And now we multiply by the original f of x, which I should put some parentheses around. We have x minus cosine of x. Now that's cool, but we're not entirely done. We can do some simplification. So I'll write it up here. 1 plus sine of x times ln of 2x cubed plus 6x. That's just the same thing. We're not going to simplify that. It's already there. So we'll have 1 plus sine of x multiplied by ln of 2x cubed plus 6x. And now we're going to be adding. We can put all of this into a fraction, so it would be 6x squared plus 6, some parentheses, multiplied by, parentheses again, x minus cosine of x. It's hard to tell, but it is x times cosine of x, all over 2x cubed plus 6x. Now this is our derivative. This is what f prime of x equals. So f prime of x is equal to all that up there. Now that sure is a lot, and that is a pretty basic rundown of product rule. And just for fun, let's go and see what that function looks like. So we have 1 plus sine of x times the ln of 2x cubed plus 6x plus here oops 6x squared plus 6 cosine of x minus cosine of x. This whole thing is over 2x cubed plus 6x. What a beautifully, wow, that is definitely a function. That's actually kind of cool. I didn't graph this out earlier, but that is a function of, it's still periodic, but I believe it's maybe, I'm not super in tune with the wave functions, but I think its magnitude or wavelength or something increases as your x gets larger, which is kind of cool, kind of a cool function. It looks like it increases pretty slowly though, like 18.919. Yeah, that is a slowly divergent function, which does kind of look kind of cool, and is undefined for anything 0 and below. It approaches 0, so it's also got an asymptote, which is kind of cool. So yeah, that's product rule. Hope you guys like the video. My 1-year anniversary. It is currently 11:52 p.m. So if this uploads at the right time, it'll actually be my 1-year anniversary video. So yeah, I should do that now. Thank you for watching.